Today, I'm going to talk about manufacturing. I'm going to show you how some manufacturing technologies that we use today generate huge amounts of waste material. And I want to show you how new technologies will make manufacturing more sustainable in the future. Manufacturing is a huge area, so in my talk, I'm just going to talk about one area, the production of aircraft structures. These are the large metal parts that sit under the skin of the aeroplane, and they give it the strength and the stiffness that it needs to fly. I'm sure you've all heard the hype about 3D printing over the last decade or so. You can't have missed all the headlines. Maybe you remember the excitement about 3D printed bicycles. Maybe you remember the court case about a 3D printed gun. Some people have said we will all have a 3D printer in our own home, and we'll 3D print spare parts as and when we need them. 3D printing is predicted to be around the $3 billion market next year, so it's already a pretty big industry. If you stop to think about it, do you have any 3D printed products? So where are all those 3D printed parts? My talk today is about additive manufacturing. It's just the more formal name for 3D printing. And it gets its name because parts are built up layer by layer to create an object. And it's in contrast with some conventional manufacturing processes that are subtractive. Material is removed to create the part. Maybe it's easier to think of an analogy. You could think of additive manufacturing as a bit like creating a sculpture from pieces of clay. You progressively add pieces of clay until you reveal the form of the sculpture that you want to have. And in contrast, you could think of subtractive manufacturing as being like creating a statue from stone. So you start with your large block of marble and you progressively chip away, again, to reveal the form that you want. And I suppose you can easily see that the additive approach uses less material than the subtractive one. And it also gives us some new design freedom. But we'll talk a bit more about that later. So there are lots of different additive manufacturing processes. They can manufacture in metals, in polymers, in ceramics and paper, even in food. But today I'll just talk about metals. So I'm going to talk to you about metal additive manufacture. Maybe you've previously seen metal additive manufactured parts. People often show them around, a bit like this small ornament. They're fine and intricate, and they're often in shapes that can't be manufactured any other way. This type of additive manufacturing uses powder as its material source, and thin layers of powder are melted with a laser and built up to produce this fine and intricate structure. But the problem with this kind of additive manufacturing is it's too slow and too expensive to scale up to the size of the aircraft parts that we want to produce for our aircraft. So I'm going to introduce you to an alternative form of additive manufacturing called wire and arc additive manufacturing, which allows us to build much larger parts. So this time, the manufacturing process is controlled by a large industrial robot. At the end of the robot arm, there's a welding torch, and wire is continuously fed down the robot arm to the welding torch, which deposits a bead of metal and, controlled by the robot, builds up the part layer by layer. I brought a small example of a wire and arc additive manufactured part with me today. I only brought a small one because they're pretty heavy. We can build parts more than 10 times the size of this one. So why do we need to use this new technology? Why can't we go on as we are today? I'm going to tell you the story of just one part to try and illustrate the challenge. This part is an aircraft wing rib. It's one of the large structural parts in an aircraft. It sits inside the aircraft wing, and it helps to carry some of the air loads and maintain that nice, smooth, airful shape that the wing has. The example we're going to look at is about 2 meters long, weighs about 20 kilograms, made of aluminium. And you can see that the shape is made of a whole series of thin walls that are interconnected together. And that design gives it the stiffness and strength it needs while being lightweight as possible to allow it to fly. Today, a part like this is made with subtractive manufacturing. It's manufactured from a single block of aluminium. Blocks of aluminium in this size are very difficult to produce. Very few suppliers can produce them. So the manufacturer has to order it well in advance of when the manufacturing takes place. In fact, sometimes they have to order several months in advance. And for a new aircraft, that means that the design might not yet be frozen. So then they order an even bigger block just in case, and the lead time gets a bit longer. So once the manufacturer has received the block of metal, the next step is to use a machining process, subtractive manufacturing, to progressively remove all of the unwanted material from the block. So the part is gradually revealed from the block of aluminium. To produce this example part, 95% of the block of aluminium is machined away. I want us to stop and think about that. We purchase a block of aluminium weighing 500 kilograms. We machine away 480 kilograms of aluminium before it's ever been used, send it off as scrap to be recycled, to reveal a part that weighs 20 kilograms. And of course the metal can be recycled. It's generally used for lower value applications like aluminium drinks cans. But you have to agree it's a huge amount of waste material. And every aircraft that's manufactured would have many tens of parts like this one, and other similar parts that are made in even higher value metals like titanium. So how could we make the same part using additive manufacturing more efficiently? Well, this time we start with a large aluminium plate. This is the build plate that the part will be built on. And you can see the example here is still sitting on the build plate that it was built on. The manufacturer orders the build plate. They also need to order the rest of the material in the form of reels of wire. But the reels of wire are stock items that can be held in stock in the factory. So we don't have that long lead time problem we have with the subtractive manufacturing approach. The additive manufacturing is then used to progressively build up the part, layer by layer, to produce the final form. And eventually, the part is cut out of the plate to reveal the final wing rib, using much less material than we used before. So I hope you can see that the additive manufacturing process is more efficient than the subtractive one. It generates much less waste material, has a lower lead time, and overall uses less energy than the original approach. The additive manufactured part still has to be machined to its final form. I think perhaps people in the front row might be able to see that the surface finish has a slightly wavy surface. So it still needs to be machined, but only a thin layer of material is removed all over. So it's much less waste than we had with the additive approach. Additive manufacturing has the potential to save many tons of scrap metal for every aircraft that's manufactured. And many hundreds of aircraft are manufactured every year. But there are some other benefits too. Because as I said before, the additive manufacturing process gives us new design freedom that we don't have today. And that means we can design optimized parts that are lighter than the parts we have in aircraft today. And lighter parts means a lighter aeroplane. And a lighter aeroplane means a little bit less emissions every time the aircraft flies. And better still, if the part needs repairing in the future, damaged regions can be machined away and then rebuilt using additive manufacturing. So we can reduce the need for spare parts in the future too. So back to that hype about 3D printing. Okay, so you may not have any 3D printed products today, and you may not have a 3D printer in your own home. But in the future, there will be 3D printed parts in the products you use, whether in the aircraft you fly in, the cars you drive, or even in your own body as replacement parts, helping to make manufacturing a bit more sustainable in the future. Thank you very much.